I could, but I don't want to do that. They're not actually supposed to cover up the windows. But anyway, moving on. That's a conversation for the time. All right, so the mole. The mole is a number kind of like a dozen. It was investigated by a number of people who were investigating gases. Specifically, this guy named Avogadro did a lot of investigations with gases, and he found some interesting relationships between ratios of number of molecules and grams. So because of his work, the mole is named for him, kind of. There's this number, and it's 6 times 10 to the 23rd things per mole. It's called Avogadro's number. He didn't come up with it, but it's named for him because of his work that he did when he was investigating gases. And he was like, oh, it turns out there's the same number of molecules, this many grams. That's interesting. And it's a really cool ratio that we're going to use a lot. Now, if you like lots of numbers, it's 6.022137 times 10 to the 23rd. 6 times 10 to the 23rd is fine for me. If you don't want to go 6.022, that's fine. 6 times 10 to the 23rd works great. Okay, now, since we're going to be using this number a lot, we should probably talk about how to put exponential notation in our calculators. Some people put it in different ways. I'm going to show you the long way and the short way. So, the long way is to go 6 times 10 caret 23. That might be how your math teacher taught you how to do it. Look familiar? Okay. But there's a much, much easier way. The easier way is to go 6 EE 23. If you have one of the yellow calculators, I've circled the EE key in silver. It's right here. Some of you might have an exponent key. If you have one of the old TIs, you have to go second comma. Okay? But the EE, that means times 10 to the whatever. No, it's only, if your calculator has one E, then, well, that's what it is. So the EE takes the times 10 to the whatever into account. It's basically, it's called exponential notation. Scientists call it scientific notation. So if you liked it the long way, 6 times 10 caret 23, great. If you like the better way, 6E 23, better. And here's why better. You guys have this reliance on calculators, but you don't realize that calculators work. They don't think. So if you put this number in, does the calculator think this is a number? No. The calculator thinks this is a function with 3 operations. A 6 multiplied by a 10 raised to a 23rd power. The calculator sees this as a function with 3 operations. It doesn't see it as a number. Now, why is that a problem?
Because it doesn't give us the scientific notation.
No, it'll still give you the same number. But why is it the fact that this thinks it's a function and not a number? Why is that a problem when you're actually doing math? Exactly. It screws up the order of operations. So, remember order of operations?
Yes.
PEMDAS. Okay. So if you're dividing this by a negative number, that negative number is going to screw up your number. It's going to give you a number that is off by 1 power of 10, and you're not going to realize it. Only you're like, how come the people using the EE keys are getting a different number than the people who are using the caret key? Because the people in the caret key are screwing up their order of operations. If you rely upon using the caret key, and you don't want to make your math teacher angry, you have to do one more step. What do you have to do to keep it from messing up the order of operations? Put it in parentheses, exactly. So that is a lot of buttons to press, but if you like that caret key, you just knock yourself right out. I like the E key myself because it's faster, you can press less buttons, less chance of messing up. Okay? So again, that's my spiel. If you're not putting the whole, if you're using the caret key but not putting the whole thing in parentheses, and you're getting a number that's off by a power of 10, that's on you, not your calculator. It's not Texas Instruments or Casio, or it's not their fault, it's your fault. Okay, so the mole is a big number, 6 times 10 to the 23rd. If you had a mole of softballs, those little orange or yellow or green softballs, if you had a mole of softballs, it would basically occupy the volume of the Earth. Yeah. If you took all of the cells in your body and all the people of the planet, that's how many, a mole would be that many cells on the planet. If you took all 7.2 billion people and you multiplied by them the trillions upon trillions of cells you have in your body, that's about 1 mole. If you took a mole of basketballs and you tried to fill them around the Earth would become so big it would be big as Jupiter. Basically, it would be like 10 more Earths of basketballs. And here's the really cool thing. A mole of sulfur atoms occupies that. That's a mole of sulfur atoms. 32.1 grams of sulfur is a mole of sulfur atoms. 32.1 grams. The molar mass of sulfur is 32.1 grams. This is a mole of silicon. Yeah, silicon's not like a goo, like silicone. Silicon's actually kind of a shiny bluish crystal. This is 1 mole of silicon atoms. 28.1 grams. Guess what the molar mass of silicon is? 28.1 grams. Some of you are seeing the pattern, and some of you are talking to your neighbor. This is 1 mole of copper atoms, disguised as old pennies. This is 1 mole of copper atoms. It weighs 63.5 grams. Guess what the molar mass of copper is? 63.5 grams. Some of you are seeing the pattern. This is 1 mole of tin. 1 mole of tin. 118.7 grams. Guess what the molar mass of tin is? 118.7 grams. So you seeing the pattern? The mole and the molar mass are very well related. It becomes a very powerful tool. If you look at the molar mass on the periodic table, that is the mass of 1 mole of those atoms. That is the mass of 6 times 10 to the 23rd of those atoms. So 1 mole of bismuth atoms would weigh 209 grams. So if you have 209 grams, you have 1 mole. If you have 1 mole, you have 6 times 10 to the 23rd atoms. Can we measure atoms? No. Can we measure moles?
Yes.
No. Can we measure grams? Yes. So the mole is the bridge between things we can weigh, grams, and things we can't weigh, atoms. Make sense?
So if you think about it, grams are all the mole acts as like sort of midpoint.
Exactly. Yep. The mole is the bridge between things we can weigh, grams, and things we can't weigh, atoms. For each element, yes. Yeah. Every element has a different molar mass because their density. But if you look at the periodic table, you're like, oh, sodium is 22.99. Let's round it up to 23. Sodium on the periodic table is 23. If I asked you to weigh out 1 mole of sodium, how much you bring it back? 23 grams. See how that works? All right. This is nickel. This is a mole of nickel shot. Shot basically means balls. This is a mole of nickel shot. If you look at nickel, ooh, can't really see it very well. But if you look at nickel, nickel has a molar mass of 58.7 grams. If you were to weigh this, how much would it weigh?
58.7.
58.7 grams. Are you seeing the pattern?
Yeah.
Cool. So it's a hugely powerful tool that we will use a lot. Basically, we're going to use this relationship and this idea a lot. So again, do I care if you use 6.0222213? Do I care about that?
No.
No. 6 times 10 to the 23rd, I'm happy. Okay. And do I care which way of exponential notation you use?
Yeah.
No. As long as if you're using this way, you put it in parentheses.
Year.
All right, I've got the numbers. So again, you don't need to do this math, but guys. So if you went to Krispy Kreme, do they have Krispy Kreme here still?
Yeah, but it's not in Boulder City.
Oh, okay. So if you went to Krispy Kreme and you got 3 dozens, how many donuts do you buy?
36.
36. What did you do in your head?
Multiply.
You multiplied 3 by 12, right? Same thing with moles. If I say you need 3 moles, you're multiplying 3 by 6 times 10 to the 23rd, and you're getting 1.8 times 10 to the 24th. Okay. Half a mole is not 6 times 10 to the 23rd, but 3 times 10 to the 23rd. All right, cool. So this is the part where we do a little bit of mathy things.
Oh boy.
Yeah. So the molar mass is the mass of 1 mole of stuff on the periodic table. Your yellow periodic table would probably be a good idea of what we're doing. If you're looking at just an atom, it's really simple. You just go copper. There's copper right there. So when you find copper, what is the molar mass of copper? 63.55. So that means 1 mole of copper is going to weigh 63.55 grams. If you're looking at atoms, it's very simple. You just find the box, read the number. However, if you are looking at molecules, you have to add whatever you have together. Okay? So, for instance, if I was making a little car and it's like, okay, my car is going to need an engine, a body, and 4 wheels. If I weighed the engine, and I weighed the body, and I weighed 4 wheels, would it make sense the car would weigh the sum of those things?
Yes.
And that's what happens with molecules too. You just add them up. Okay. So molar mass of nitrogen.
20.
Double that.
28.
28. Nitrogen, remember, nitrogen is one of the diatomic molecules that can never be alone. So nitrogen, N2, is going to be 14 times 2. Okay? Let me pause right there. I've talked a lot. See how you're doing. If you're comfortable so far, give me a thumbs up. If you want me to review something, wave your hand around so I can see. Okay. What can I do review? Because nitrogen is a diatomic molecule, so there are 7 molecules, or 7 atoms that are never found alone, and they're called diatomic molecules. Di-2-atomic, so 2-atom molecules. They're never found alone. Nitrogen will always be found in a molecule of some kind. So it's never 14, it's always 28 in its elemental form. So other ones are also like that. Oxygen, what we're going to call the halogens, fluorine, chlorine, bromine, and iodine, and lastly, hydrogen. So there are 7. All of them are gases except for bromine and iodine. Bromine's a liquid, iodine's a gas. That's all. All right. So give me a thumbs up. You're ready to move on. Moving right along. All right. Next, what is the molar mass of CO2? Kenan.
Well, I don't know before that.
Okay.
When you're for the 6.02 times 23 or times 10, you know what I mean?
Yeah.
What like formula to find the molar mass do you do? Where do you put that in?
We're not ready yet. We are going to go from grams to moles to atoms in a little bit. Right now, we're just working on molar mass.
Like a little bit today or a little bit in the week?
We'll see. I have a schedule, but I'm also flexible. So, CO2, carbon dioxide. That gas that you're messing up the world with. You're like, stop breathing. You're causing global warming. So, carbon dioxide is just like it sounds, a carbon and a di of an oxide. 1 carbon, 2 oxygens. This little number down here is called a subscript. Literally, below writing subscript. Like a submarine, below writing subscript. Question or answer? Okay.
So when you're like writing it out, so like like CO2 and then like the answer? Is it just you just write
G per mole. Yeah, gram per mole. Gram per mole. This would be grams per mole. Kind of like miles per hour. Okay. With your fingers, show me what the number is. Is it 11? Is it 21? Is it 22? Is it 33? It's 44! That's right, it's 44. So the molar mass of carbon dioxide is 44. You get 12 for the carbon, 16 for each oxygen, for a grand total of 44. 44 Club, like and subscribe. Okay.
Oh, ridiculous.
Yeah. Rick, get that bell on.
No, that's the name of the.
It's awesome. Yeah, if you, it's
ridiculous.
pretty much the coolest YouTube channel that exists.
I have it.
So, okay. So that's where we are so far. Give me a thumbs up if you understand what we're doing so far. Hey, wave your hand around if you want to talk about it some more. All right, moving on. So now we're going to practice using the periodic table to calculate molar mass. They are going to increase in complexity as we go. So calcium, find calcium on the periodic table, write it down, show your neighbor, see if your neighbor agrees with you. Okay, so with your hands, what did you get for calcium? 40, 40, 40, 40, 40, 20, 40, 40, it's 40. Okay. So calcium is 40 grams per mole.
Yep.
Okay. Now this is kind of interesting. Again, chlorine is diatomic, so find chlorine on there. I don't care if you round before or after, as long as you're in the ballpark, I'm happy.
Why am I choosing like that?
Wrinkle off. So hydrogen up in the upper left corner.
How's he gonna get out?
And then oxygen, nitrogen. And then the 4 group 17 elements.
Yeah, incorrect.
And we don't care about astatine because astatine is so weak, so unstable, we just don't care.
But hold on, the 4 cheeses. I don't understand, like you said.
The 4 group 17 elements. So fluorine, chlorine, bromine, iodine. Brinkelhoff. Brinkelhoff. Brinkel Hasselhoff. Okay, so chlorine. Periodic table tells you it's 35.5. You double it, you get about 71.
Yep.
Again, if you round before or after, I'm not really going to care. If you say 70, I'm going to be like, that's all right. I'll deal with that. Now, there's a compound that, by sheer coincidence, the physics or chemistry AP kids are using today, and that's calcium chloride. So, what's calcium chloride? By some strange coincidence, they're actually
I think he's writing the word
calcium chloride solution.
too much,
Lab number 3.
in my opinion. But
No, actually, what are you trying to find?
what?
Hey! Addition is commutative. So, yeah, so a calcium with 40.1, 2 chlorines at 35.5 each. 111?
Yeah.
All right, cool. Yes. Well done. The teamwork in the back, they're like. All right, next. H2O. This one's going to be really hard to do with two hands.
Oh, right.
That works, yeah. Very creative. Yeah, 18? 18? Okay. 18. So, again, this subscript refers to only what is right before it. Just like this subscript only refers to the chlorines, this subscript only refers to the hydrogens. Ooh. Parentheses? Oh no! Okay, the parentheses work just like algebra. This too refers to everything that's before it, so that means there's a grand total of 2 oxygens and 2 hydrogens. So this is Ba with 2 H's, or 2 OHs. You can think of this as Ba and then an OH and an OH. This chemical is called barium hydroxide.
Am I right?
Yep.
Is there such a formula if I'm making elements?
It's called IUPAC. IUPAC. And we're going to learn it when we do nomenclature, which is November. We're going to learn the system. It's a very simple system, and if you're paying attention throughout the fall, you'll actually pick it up ahead of time. You'll be like, oh, it's just from patterns. So, barium hydroxide, calcium chloride. Did you get 171? Okay. If you got 171, give me a thumbs up. Okay. If you only